What's up, guys? So 26. Okay, so before I start, please subscribe to my channel if you haven't done that. Okay, if k is a real number, define on this sine over 1 over x when x non-zero, and ask about how to define x equals 0, and let the graph will be a non-connecting set. This problem is easy. That if you see that sine over x, 1 over x will fall into 0, 1 region, and then when x goes to 0, then this term will escalate very rapidly. So basically, you have this, and you need to let x equals 0 to be disconnected. So the easy way is you just choose any point which is larger than 1 or smaller than minus 1. Yeah, so basically you just choose larger than 1 or smaller than minus 1. So the answer is E. The answer is E. So this problem is simple. 26 is simple. Okay, 27. So it gives you three tuple ABC, and let's say that when x more than 0, when x less or equal to 1, then the function of x defined to be x. When x is greater than 1, then we define it as a squared plus bs plus c, and then we want x equal to 1 is differentiable with respect to x, because it already differentiable. So the only question point is x equals to 1. Okay. So to be differentiable, we need f of x. So the first things the f of x need to be continuous. So when x approximate to approach to 1, the left hand side and right hand side must be the same. So we have 1 equal to a times b plus a plus b plus c. And the second is the derivative must be continuous also. Must not continuous, but must be fit left hand side, right hand side. So derivative of x smaller than 1 is 1, and this is 2ax plus b. So these two must be the same when x equals to 1. So 2a plus b. So we can solve these two equations. So we have two variables. But we have three variables but two equations. So we need to solve it. So basically, okay. So from this one we have b equals to 1 minus 2a, and this 1 equals to a plus 1 minus 2a plus c. So this tell you that a equals to c, c equals to a. So the point can be written as a 1 minus 2a and a. So this is the tuple of ABC. So the answer is A. The answer is A. That's it.